There's an axial line. There's a reference axial line, and there's an equatorial line. This is for our reference we are drawing. The bar magnet will not produce these dotted lines. It's a three-dimensional. I'm showing only the plane diagram. It's a three-dimensional. No two lines should intersect. There's also one has to take care. There's the direction of the magnetic field. There's a north pole and south pole. Inside the bar magnet, the lines of force will be from south to north. External to magnet, the lines of force will be from north to south. It all depends on the magnet, how many lines I'm going to draw it. This is a bar magnet. This rectangular block is a bar magnet. Yeah. Now, if you draw a tangent at any point, you want the magnetic field. You draw a tangent. The tangent will give the direction of B bar at that particular thing. So on the axial line, how the B bar, on the axial line, the B bar will be along M bar. Always show that M bar. On the how the B bar will be on the axial line, it will be in the direction of M bar. Similar to electric dipole, just correlate, it will be on safer side. Then here it will be opposite to M bar on the equatorial line. Of course, the magnitude will be different. I'm just showing only the direction of this one. So anywhere if you want here, B bar here you draw a tangent. This will give the direction of B bar. So you want at this particular point, draw a tangent and give the direction of B bar. So this is called as axial line. This equatorial line. In SURMA, what is calling this called a broadside on position, hand on position, hand, because this is the end of the magnetism, hand on position, broadside on position. This is a broader side, no? Broadside on position, that equatorial line or broadside on position, axial line, end on position. Both things are being defined in NCERT. If you look at the CBSE textbooks, no, in exams, find the magnetic field on the end on position. Means it's asking somewhere at a distance r. Means he's asking here on axial line. So the terminology here is end on position. It is called as equatorial line or broadside on position. NCERT book used equatorial axial line. SC Verma used broadside on position, end on position. Both are justified in exams. Either of words can be asked. So get familiar with both the things. So how the lines of force, and they are like a not like a elliptic lines of force. They'll originate at north, positive charge, terminate at like a negative charge. But here what happened? they're not, they don't have anything called like a origination and termination, so they are continuous. So therefore, b bar dot ds will be 0, no? Integral of, this is what I think the Gauss law for magnetism. So magnetic lines of force, what shall we call it, a continuous? They're always in a closed path. They don't have any origination or termination point here. Whereas the electric lines of force are discontinuous. So in, or we can also put in form of sentence. Magnetic lines of force are continuous. So just get this information. Now, what we are interested, we are definitely very much interested to know the field due to surrounding bar magnet. Means at several points, how to calculate the field. So can we go back to the electrostatics? Yes, we have brought some several methods. So same thing, I'll continue. So now, B bar